Okay, we're going to take a look at angles. Ray OA, this side right here, is referred to as your initial side. Your initial side is always going to be on the positive x-axis if there were axes going over the top of this. So if you had your axes coming down like this and then coming over like this, your initial side is always going to be on the positive x-axis. Your terminal side is then OB, ray OB, with our vertex being O. In our angle and standard position, as we said, has your positive x-axis being your initial side. Now, if your angle starts here and rotates up, it's referred to as a positive rotation. However, if your angle starts here, rotates backwards all the way around to this, it's referred to as a negative rotation or a negative angle. And so if we would take our initial side and rotate it up, we get a positive angle. However, if we take our initial side and rotate it backwards to here, we get a negative angle. So whether you rotate clockwise or counterclockwise makes a difference on whether it's a positive or a negative angle. Now, a coterminal angle to 30 degrees. 30 degrees is about here. A coterminal angle is another angle that maps to the same location. Well, we could also get to the same location, not by just going up 30 degrees, but we could go up 30 degrees and then go all the way around. And well, when you go all the way around, that's a 360. So we were at 30, then went all the way around 360, so that's a 390. Well, instead of just going up here once to 30 and then going around once, you could go around a second time and get to that same location. And so then you'd be going up your 30, going around a 360, going around another 360, and that's where a 750 comes into play. It is possible to get to that location. Instead of going up, once again, you could go backwards. How far would you have to go backwards to get to the same location that a 30 would be at? Well, you don't want to go backwards all the way around to here because that would be a negative 360, but we were 30 from that. So you're really going backwards a negative 330. Or it is possible you could go here, go backwards your negative 330, and then go backwards another full rotation, which would end up being a negative 690. So let's go ahead and take a look at this. We want to draw in a negative 45 degree angle. We know that this is 0 degrees, this is 90, 180, 270. Well, if we're dealing with a negative 45, we need to start here, and then we've got to rotate down. This one right here would be negative 90. This is 0. Negative 45 is exactly in between those two. So this would be your negative 45 degrees. Looking at the next one, we have an angle of 215. Well, we're going to start here, rotate this way, that's 90, still not to 215. Rotate to here, that's 180, still not to 215. But this is 270 down here. When you look at your 180, which is here, 215 is really 35 degrees past that, so that's about in here. So now we would have our angle going from here to here of a 215 degree angle. Well, let's take a look at the next one here. We have our 405. Well, we're going to have to be here. If we go all the way around once, that's 360. Now, how far beyond 360 is our 405? Well, it's 45 beyond that, so we're going to be up here. So our 405 starts here, goes all the way around, and then comes back to here. This is your 405 degree angle. So let's take a look at a different way to measure angles. Angles can be measured in degrees, but can also be measured in what's referred to as radians. Radians is defined to be your arc length That's the curved distance going around your circle divided by your radius. Well, let's look at how many radians are in one full revolution. We know one full revolution is going all the way around the circle like this, and we call that your circumference. The formula for your circumference going all the way around, you should remember, is 2 pi r. But so it's 2 pi r, but then you got to divide by your radius. R over r drops out. So it's 2 pi for one full revolution going all the way around. You also know that 2 pi is the same as 360 degrees. Because you know one full revolution around is also 360. So 180. 180 is halfway around. Halfway around your 2 pi then would just be pi. A quarter of the way around your 2 pi is pi over 2. 270, you know, is 3/4 of the way around. 3/4 of your 2 pi is 3 pi over 2. So pi radians is equal to 180 degrees. Then we have pi over 180. That's what you want to multiply by when you're converting your degrees into radians. If you had the fraction of 180 degrees over pi, you need to convert that, use that to convert radians into degrees. And that's what we want to look at here. We want to go ahead and convert our 35 degrees into radians. Well, these are the two fractions that we could be dealing with. One of these is going to be helpful, one of these is not. Let's consider this first one. Suppose we multiplied by this. We're trying to eliminate our degrees, getting our degrees to drop. But here we'd end up with degrees on the top times degrees on the top, which would give us degrees squared. They don't drop. So let's try the other one. This one here, you'd have degrees on the top of your fraction up here. You'd have degrees on the bottom down here. The degrees here would drop with the degrees here. And so then we end up with 3 pi over 4. You might be wondering why. Well, there's definitely a pi on the top, so we're going to have a pi on the top. Your 135 divided by 180 is 3/4. And you can always go ahead and take your calculator and go 135 divided by 180. It's going to give you 0.75, and you can always fractionize that, and you're going to get 3 over 4. Just remember you need to have a pi in your final answer on the top. So let's take a look at this one here. We want to end up with degrees. Suppose we started out with this one here. We want to end up with degrees in our final answer. Notice this is really over 1, so we have degrees on the top. However, when you look at this one here, we have degrees on the bottom. That's not going to allow us to have degrees on the top, so we're not going to want to use that. We're going to want to use this one here, because that's going to leave us degrees on the top. You'll then realize, oh, we have a pi on the top, a pi on the bottom, they're going to drop. So now all we have to do is, with our calculator, take a 7 times 180 and divide it by 4, and that's where we get a 315. Let's go ahead and take a look at this one here. Once again, you want to look at your units. Well, having this one right here with degrees on the top allow your degrees to drop out since we're starting with degrees. No, it won't, so we need to have the degrees on the bottom. Our degrees on the bottom, degrees on the top drop, degrees on the bottom drop. Realize you have a 0 here, drops with that 0. And then you could also think, if you wanted to do this in your head, oh, 24 and 18. They're both divisible by a 6. Your 24 divided by 6, and your 18 divided by 6, and you know you have a pi. Now, if you're not able to reduce fractions in your head, that's fine. Just know you're going to end up with a pi in your answer. So you got to have a pi in the top, and then just take 240 divided by 180, type that into your calculator, and turn it into a fraction. Over here, we need to end up with degrees, so we need to have degrees in the top. Notice now that your pi's are going to drop. Then you have 180 divided by 3, and that's where the 60 comes from. This is your unit circle. This first green dot here can be measured either as 30 degrees or in radians as pi over 6. The coordinates of that first green dot is root 3 over 2, comma, 1/2. Here's your 45 degrees, or it's pi over 4. The coordinates on your unit circle, notice it's a unit circle, your radius is 1, so it's 1 unit from the origin. Coordinates of this point, square root of 2 over 2, square root of 2 over 2. And then here's your 60 degree angle. 60 degrees, or pi over 3. The coordinates are 1/2 and square root of 3 over 2. The ones on the outside here are your tangents. Tangent of 30 degrees is this, tangent of 45 is 1, tangent of 60 degrees is over here. Now notice, this blue point coordinates here matches closely with this one here, but since you're going to the left, instead of having a positive x coordinate, it's negative. Matches closely with this blue one down here. Directly below it, so it's got to have the same x coordinate of negative 1/2, but instead of being up, it's down, so that's why your y coordinate's negative. This blue coordinate over here, it's directly below this one, so it's got to have the same x coordinate. But instead of being up this distance, you're going down, so that's why it's a negative root 3 over 2. Same type of patterns, work with the purple. And same type of patterns deal with the green. This is your unit circle. You will need to have this memorized. It's going to just take some time to get it in your memory, so practice with it. You're going to need to know all the coordinates with the parentheses. You're going to need to know your angle in radians and your angle in degrees. You're going to need to know the red, the green, the purple, and the blue. Let's take a look at the coterminal angles again. Now, if you're dealing with degrees like we started out this class looking at coterminal angles, you wanted to add or subtract 360 degrees because that's one full revolution. But here we're dealing with radians. So you're going to still want to add or subtract a full revolution, but one full revolution in terms of radians is 2 pi. So if you're looking for a coterminal angle to 7 pi over 3, you'd want to go ahead and add 2 pi. So you go 7 pi over 3 plus 2 pi. Well, you know you're going to have a pi in your answer, and you can either do this by hand or on your calculator. Go 7 over 3, add 2, and fractionize it. And then you would get your 13/3. Now, if you chose to go ahead and work this one out by subtracting, if you subtracted here, you would go ahead and leave your pi in your answer, take a 7 over 3 minus 2, fractionize it, and you get 1/3 or 1 pi over 3. If you subtracted a couple of these full revolutions, which would really be 4 pi, you know you're going to have a pi in your answer. I want you to go ahead and go 7 over 3 minus 4 on your calculator. You know you're going to have pi in your answer. When you fractionize that, you're going to get a negative 5 pi over